Alright, this is the video for the Chapter 5 review for the Chapter 5 test tomorrow on the 15th of December. Some important dates if you're gone, even if you're not gone, to emphasize and remember. You will have 17 items in your homework packet that is due tomorrow, Thursday, for a total of 71 points. Last day for late work for the entire semester is on the 17th. I will not budge from that date. So any late work that you have must be turned in on or before the 17th. Your semester ends on the 27th, and you have a notebook check on Friday. Friday. Tomorrow's Thursday. All right. Just in case you missed it, here are all of the items on your table of contents, 1 through 12, with the bell work, fly swatter bingo, etc. If you're missing an item like fly swatter bingo, you do need to come and see me to get that before the due date tomorrow. I'm in either this room, 602, room 603 in the afternoons and after school, and room 806 during break. This is the last page for your table of contents, item number 17 being the last item. Your system of inequalities, color by number, which was given as an assignment yesterday. If you don't have number 17 entirely completed and colored, that's okay. I just need to see that you at least attempted a fair number of them. All right, Chapter 5 review. Your first 3 questions are very simple questions. They should be give me questions. They are asking you whether or not an ordered pair is a solution of the system of linear equations. That's just a system of linear equations. So we're going to solve this. So how would I verify whether or not that point is a solution of the system? Yes. Plug it in. That's exactly what I'm going to do. Now the one thing that you want to remember is that in order to be a solution, it has to work for both linear equations in your system. So if you didn't quite hear that, once again, in order to be a solution, the point has to be a solution for both equations in your system. If it's only a solution for one and not the other, then it's not a solution for your system. You must check both. So in this case, I'm simply going to plug in y. 2 equals negative 5 minus 3. So 2, does that equal 5 minus 3? It does. So that works. I can't stop there though. I have to check the other one. So when I plug in 2, does that equal 3 times negative 5 plus 10? So we have 2 equals 5, negative 5. Okay. That's not true. So is this point a solution? No, it's not. It's simply yes or no. After those initial easier questions, I throw you a bit of a curveball with this absolute value equation. So you will have one of these on the test. Solve the equation, check your solution. So in order to solve this equation, you have to set up 2 separate systems and look at the intersection point for 2 separate graphs. We have to use our definition of absolute value in order to solve this system. So one of the systems that I'm going to set up is the following. Y equals x plus 6 and y equals negative 2x. What you want to do with that system is graph the system and find the intersection point. Notice that I did not change any of the signs. I have kept all of the expressions within my equation the same. The next thing that you want to do is set up a second system in which you change the sign of one of your systems. In the book, it changed the sign of the second expression in your equation, so that's what we're going to do. So, you still have the y equals x plus 6, but this time, you're simply going to insert a negative in front of your second equation. So I know that negative 2 is just a positive, right? That cancels out. So you want to graph both of those systems and find the intersection point. Do you have any questions about how to do that? I will provide for you on the answer sheet for the exam, just like last time. You will have the majority of which is multiple choice. You will have some that you have to write down and explain, and I will have just some extra graphs for you to use. I would encourage you to take advantage of that and use just one of those extra graphs to solve this problem. All right, to pick up where we left off, I have the two equations, or two expressions of my equation graphed, and I noticed that I have an intersection point where my x is negative 2 for the first graph, and my x is positive 6 for the second graph. Now, in your original equation, you do not have any y's, so it's not necessary to include the y in your answer. You are just looking for those x values. It is important, since we are dealing with absolute value, to check our answers to make sure we do not have extraneous solutions. So right now, this is my answer, x equals negative 2 and x equals 6. Again, it is important that you plug in those values to determine whether or not those are indeed solutions to that equation. So, for the first one, I'm going to look at my original, and I'm going to say is negative 2 plus 6. The absolute value of that is that equals the absolute value of negative 2 times negative 2. Well, in both cases, I get 4, so that does work. I want to do the same thing to the other one, the other x value. So is 6 plus 6, absolute value, that equal to the absolute value of negative 2 times 6. What do you think? Is the absolute value of 12 equal to the absolute value of negative 12? Yes, so that does work as well. Now these graphs are the same template that you'll be getting on your exam tomorrow. You will have 3 extra graphs that you can use for whatever means necessary, and they will look exactly like that. And again, I would encourage you to take advantage of those graphs for this problem. Do you have any questions? All right, moving along. You will have a few inequalities that you will just have to graph in a coordinate plane. These will be multiple choice as well. So it's not a system that we're looking at. We're just looking at a single inequality, and we're told to graph that. So the biggest thing to remember for these is solid versus dotted and the direction of your shading. So for the first one, we have y is greater than 4. For the second one, x is less than or equal to negative 3. So for the first one, is it going to be a solid or a dotted line? Dotted. For y's, we have to decide if we're going to shade above the line or below the line. Are we going to shade above the line or below? Above. So in this case, am I going to have a horizontal or vertical line? Horizontal, okay, and it's dotted. going to look just like this. Dotted line, arrow, and I'm going to shade above. Now, if the above-below thing confuses you, you can test points to determine shading as well. So I will show you that one more time, just in case looking at it in from this perspective is confusing to you. One option that you can do if you're confused about deciding where to shade is to test points. You can test any point that is not on the line itself. So 0, 0 is typically the easiest point to test. So all I need to do is say to myself, when I plug in 0, is that greater than 4? It's not. It's not a true statement, so I will not shade towards the point. I will shade away from the point. Okay? If it was true, then I would shade downwards. Same thing for x's. Okay? If the left-right thing doesn't make sense to you, then just test a point that is not on the line itself. So, am I solid or dotted for this one? Solid. Am I left or right? Left. It's going away from the x, it's left. It's going towards the x, it's to the right. So I'm going to find negative 3. I'm going to make a solid line this time. And I'm going to shade it to the left. You'll have others that are just simple. Y equals mx plus b. They're in slope-intercept form. And then it's just graphing that line, determining whether it's solid or dotted, and the shading. Okay, do you have any questions on this? All right. Now we're going to start looking at graphing systems of linear inequalities, which is 5.7. Okay. So we're just doing exactly what we just did, except that we're graphing two lines and finding the intersection of the shaded regions. It is very important on your test tomorrow that you are very clear and concise about what region represents your solution. So if that means shading it extremely dark, that's what it means. But you must be extremely precise about it. Okay? You will have some that are multiple choice that will do the shading for you, and that's nice. But you must, again, on the ones that you do by hand, make sure that your shading is dark enough to where I understand what your solution is. So in this case, I like to think about these inequalities first in terms of equations. Think about what the b value is, my y-intercept, and my slope. So what is my y-intercept for this line? Zero, right? I don't have anything added to it, right? It's just an implied 0. What's my slope? Negative 2. Okay, so very simply, I'm going to graph the y-intercept 0, 0. I'm going to go down 1, 2 units to the right 1, and up 1, 2 units to the left 1. What kind of a line is this going to be? Solid or dotted? Solid. So I'm going to connect the dots, make a solid line, and in what direction am I going to shade? Above. So I'm looking at this line and I'm going to shade above the line. Now in this case, you cannot pick 0, 0 as a test point. If the above-below thing, again, doesn't work for you, then just pick the point 1, 1, okay? Or some other point that is not on the line and make a decision if you're going to shade in that direction or not. So if I were to pick 1, 1, for example, is 1 greater than or equal to negative 2 times 1? Well, it is, right? 1 is greater than or equal to negative 2, so I shade towards the point 1, 1, which is right here. Does that make sense? Okay, two ways to look at it. Now, my second line, is that solid or dotted? that a horizontal or vertical line? Horizontal. Perfect. So I'm going to make a dotted line, dotted horizontal line, with 0, 1 being my y-intercept. Am I going to shade above or below? I'm going to shade above. So on your exam, you want to darken or highlight this region here in the top right corner, because that is the intersection of your shaded region. Does this make sense? Do you have any questions? All right. Let's do one more and then we'll take a bit of a break. You will have one question, and it's multiple choice, that has you graph 3 inequalities for a single system. Okay? So we're going to do that. Pay special attention especially to the second inequality. So for these, I encourage you to get it into the form y equals mx plus b, just with the inequality, because that'll help you with the direction of your shading. So the first one, I'm just going to subtract x on both sides. So when I do that, I get y is greater than negative x plus 4. Now the second one, when I subtract x on both sides, I end up with negative y is less than negative x minus 1. I have to get rid of that negative in front of the y. What do I have to remember when I divide by a negative? I have to flip the inequality sign. So what I actually end up with is y greater than, and when I divide by the negative 1, the entire thing gets divided. So this is now a positive x plus 1. Before I move on to the third inequality, do you have questions on that one? Okay. And then of course that one's already has the y isolated for us. Y greater than 7. So I'm going to graph each of those individual lines in the respective colors that I have on the board, and then we're going to shade, okay? Shade one at a time. So first one, y-intercept of 4, down 1 to the right one, or up 1 to the left one. Down 1 to the right one, or up 1 to the left one. Solid or dotted? It's going to be dotted. And for that inequality in brown, am I going to shade above the line or below? Above. Shade above. All right. Now let's move to the green inequality. You have a y-intercept of 1. And you are going to move up 1 to the right one, or down 1 to the left one. Is this going to be a solid or dotted line? Dotted? And take into account when you flip the inequality sign, is it going to be shaded above or below that line? We're looking at the flipped one, right? So it says y is greater than, so above, right? So we're going to shade above. Okay, so we know where our intersection is for our red and blue so far. We have one more line to graph. That's also dotted. That's a horizontal line. at y is greater than 7. I'll use a different color for that. I'll use black. This one. So we find 7 horizontal. Is the shading going to occur above that or below it? Above it. So, the region that contains our answer is this one right here, with the pink and the blue. We have the border of that right here with the black and the green and the brown as the side borders, right? So it's just this region here. So on your exam, okay, you want to darken this little area that's closed off again by the brown line, the green line at the corners, and the black line here at the bottom. You want to darken that, okay? Do you have any questions? None? All right. So somebody asked me a question while we are on a break here about shading the intersection. Is it necessary to shade everything else? You don't have to shade anything but your solution if you want to. So if you just want to think about what your solution is going to be and you just want to shade that region, you can do that. That's fine. You don't have to shade everything around it. Okay, I just do that because it can be helpful. But if you just shade the region that is your solution, that is perfectly fine. All right. We'll have a couple multiple choice questions that ask you to write a system of inequalities represented by the given graph. So, the first thing that you want to do is identify the equations of your lines and then think about them in terms of inequalities and set up your system. You have 2 multiple choice questions, so you do have options, okay? But you want to think again about the actual lines themselves in terms of equations, then in terms of inequalities. So let's think about the dotted one first. So for the dotted line, what is my b value? 2. That's my y-intercept. And then I'm just going to find the slope, okay, from point to point. What's my slope? 1/2. I'm going up 1, over to the right 2 units. So my slope is 1/2. So typically as an equation, it would be y equals 1/2 x plus 2. I know I'm dealing with an inequality, so I have to change it to an inequality. I have to make a decision on whether it's less than or greater than. So I look at the shading. Is that being shaded up or below? Above, right? So it's going to face the y. It's going to be greater than 1/2 x plus 2. So that is the first inequality in my system of inequalities. Same thing for the second one. What's my y-intercept or my b value for the second line? -1. What is my slope? My slope is 2. I'm going up 1, 2, over to the right 1. So typically it would be y equals 2x minus 1. I think about it in terms of a system. Now, is it going to be greater than or equal to or less than or equal to? Less than or equal to is being shaded below. So in this case, it's y is less than or equal to 2x minus 1. You have a couple of those. And again, you have options. Do you have any questions? All right. All right, so back to the slides here. All of the questions before this current slide, question number 7, are multiple choice questions. We are now entering the explain, show by hand, show all your work kind of questions. And those are word problems, okay? So, number 7 says you need to rent a bowling lane. On Friday nights, you have 2 options. Option A is a $20 lane rental plus $3 per game. Option B is a 35 lane rental with a maximum of 10 games. For what number of games is the total cost the same for each option? So you will have a word problem that has you look at equivalent expressions, setting things equal to each other. Okay? When is it the same? So we have to set up 2 equations that represent this situation. We have to set up a system. The very first thing you want to do, okay, and I say it on the test, and some of you will not do it, so I'm going to say it again here, and I'm going to emphasize it, okay? So if you're hearing this is very important. First step, define your variables, okay? If you do not define your variables, you will miss points on this question. So tell me what your x represents and what your y represents, or your a and b, or your m and n, whatever variables you use, you need to tell me what they represent. In this case, we're going to use x for the cost, for the number of games, the number of games. So, for option A, if you play 2 games, you owe $6 plus the $20 lane rental. For Y, what do you think that's going to represent? Huh? What is Y going to represent? What does it represent in the context of this problem? What have we not represented yet that we need to find? The total cost. Right. So for option A, for example, we need to know the number of games in order to find out how much we owe. We owe $20 for the lane rental, $3 per number of games. We don't know how many number of games, so we make that x, right? And then we're also actually trying to find the total cost, so that has to be a variable as well, some unknown that we're trying to find. So, for option A, and I'm actually going to write that here for option A. How can I express that in terms of an equation? What do you think? Perfect. Y equals 3x plus 20. So my total cost for that option is going to be 3. So $3 times the number of games plus the lane rental, which is already $20. Okay? Now the next one, option B, is a little bit trickier to think about. Option B says that it's $35 lane rental with a maximum of 10 games. So you can play 10 games, 9 games, 8 games, 7 games, 6 games, 5 games, 1 game, right? So how can I express this in terms of an equation? Any ideas? My total cost is going to be set equal to what? 35. 35, right. Because they won't allow you to play 11 games, will they? If you play 9 games, you'll have to pay 35. If you play 7 games, you'll have to pay 35. 6 games, you'll have to pay 35. Does that make sense? Yes? So it says, for what number of games is the total cost the same for each option? So how do I solve this? Yes. What's an easier way to solve this other than graphing and finding the intersection point? If they're the same, what am I going to do with those 2 equations? Set them equal to each other. I can simply set them equal to each other. And if I don't require you to graph it, why graph it, right? Just solve for x. Ain't nobody got time to graph it when you're taking a test, right? Okay? So, you know, if you need to do a little bit of shorthand stuff here, set them equal, solve for the variable, you can. So subtract 20. Subtract 20. You get 15 equals 3x. What do you get for the value of x? 5. So how many games? Yeah. So after 5 games, the total cost will be the same for either option. Does that make sense? Miss Wynn, when am I going to use this in real life? Well, here you go. All right. Anyway, moving on. You will have 2 problems that have you solve systems, one by substitution, one by elimination, and you must show work for that. I want to know that you know how to use substitution and you know elimination. If you solve it some other way, if you solve a substitution problem by elimination, you will miss it. If you solve an elimination problem by substitution, you will miss it. You must use the stated method, okay? And you must show all of your work. And I bolded it, okay? I bolded it, and I think I underlined it. So, we're going to solve by substitution. So how will I do that? Yes. 2y on both sides? Yes. I already see, remember again, substitution is often easy when I have a variable in one of my systems with a coefficient of 1, and I do in the second equation. So I'm going to isolate x and substitute it. So I get x equals 11 plus 2y. I'm going to substitute that into the first equation. So negative 7 times 2y plus 11, or 11 plus 2y, minus 2y equals negative 13. So I have negative 14y minus 77 minus 2y equals negative 13. All right. When I do that, and I combine my like terms, I get negative 16y minus 77 equals negative 13. When I add 77 to both sides, what do I end up with? Negative 16y equals what? 60 what? 64. And when I divide by negative 16, you get y equals negative 4. When you divide by negative 16, you get y equals negative 4. What do I do to find the value of x? Plug it in, okay? I would, if you're doing substitution, plug it into the equation where you have one of the variables isolated, okay? So in this case, to find x, I simply just say x equals whatever 11 plus 2 times negative 4 is, which would be what? 3, right? So in this case, x equals 3. What's my solution? 3, negative 4. Okay, this is another very important point to emphasize, okay? The point itself, literally. So, 3, negative 4. You must list this as a point. If you do not, you will miss points. So you have to show work on this problem, and you have to list your answer, your solution, that point of intersection as a point. All right, do you have any questions on substitution? Okay. You will be given the same problem, but you'll have to solve it by elimination. Okay? So the problem will not be different, solving it by elimination this time. So to solve it by elimination, I want to eliminate one of my variables. I can see that I have 2y in both of them. So I'm going to go ahead and multiply the second equation by negative 1. Multiply that by negative 1, multiply this other side by negative 1. Both sides by negative 1 using my multiplication property of equality. I end up with a system that looks like this. Negative 7x minus 2y equals negative 13. And negative x plus 2y equals negative 11. I'm simply going to add across. Make your work legible, please. And when you add across, you get negative 8x equals what?
Negative 24.
So what's the value of x? 3. Okay, that's the same value that we got for the last one. And then I want to plug that into one of my original equations. So I'm going to plug it into the second one here. So 3 minus 2y equals 11. So when I subtract 3 from both sides, or when I subtract 3 from both sides, what do I get? 8. So what's the value of y? What? Negative 4, which is the same as the value of y for the last one. So what, once again, is my solution? Right. Okay, we have one more question, and then we'll be done. Okay. Do you have any questions about these two? Yes. There are 13 multiple choice questions. I think there are 17 total. Yeah. So 4. You will have an error analysis question. Sally and Bobby are arguing about who's right and wrong. Okay? So it will have something to do with this. Something to do with no solution and infinitely many solutions. So just to remind ourselves, what does it mean for a system to have no solution? There are what kind of lines? First of all, parallel lines. Okay. So for A, a couple things. They're parallel. They're parallel, which means that they share no points of intersection, right? No points of intersection. What does it mean for a line to have infinitely many, or for a system to have infinitely many solutions? They're the same line, which means what about their points? Yes, they are the same line. It's not doing it very well. They are the same line, which means they share all of the same points. That is extremely important for the y part of it. Okay? Both of these. They share all the same points. The bonus question is creative, and it's something everyone can do. That's all I'll say. All right. Do you have any last minute questions? Yes. That's a great question. For substitution, it depends on the coefficient or the number in front of the x and y. If there's just a 1 in front of it, meaning it's just x or just y, then that's the easiest to isolate. So I knew I wanted to isolate the x here because there was just a 1 in front of it. Okay? Now, for the rest of you, to study, I will watch this video once or more than once and make sure you understand all the concepts. If you do, you'll do fine on the test tomorrow, and then you'll have a wonderful Merry Christmas.